Well, hello to my lovely students. Here we are in another lesson of our book, section 1.2, under the title of Standard Form. So, in standard form, first of all, I would like to explain it in this way that um, in our local book, there is a section regarding to this matter, which is standard form, but there is something else regarding to this standard form, which is scientific notation. Here, according to Cambridge, standard form and scientific notation are the same. That's why, since we are in this system, so I'm going to explain the topic based on this book. All right. Great. So here is it's also given as a tip that standard form is also sometimes called scientific notation. It's better in this way. All right. So that's why whenever we mention standard form, it means the scientific notation as well. Here. So let's start our explanation. Section 1.2, standard form. It's the same with scientific notation according to, again, Cambridge system. So in standard form, we use, again, I would love to ask you kindly that please, before listening to my video, I want you to prepare like a paper just like me, or a notebook, which is better, to note down what you are going to listen and what you are going to see in the video. All right. So standard form, we use standard form to write like big and small number. All right. What I mean by small number, I will make it clear later, like tiny numbers. In a short way, small number, sorry, in a short way by using standard form. How do we write numbers? Like, how do we write numbers in standard form? Like, it has two steps, by the way. The first step is, so the first step, we should move the decimal point to a place that it makes a number between 1 and 10. Just be patient. Everything is going to be clear when we go through the examples. The second step is multiply the number that we found by powers of 10. Powers of 10. What are the powers of 10? Like 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, or 10 to the power of -1, 10 to the power of -2, and it goes on like this. So these are the powers of 10. Now let me first give you some questions by myself. In like, imagine if we have something like okay, let's just go through the questions. In the first exercise, it says write this number in standard form, but be careful, still our explanation part is not completed. So all right, let's just write the second part of our explanation. So the second part of our lesson, it's about full form of a number. Imagine if a number is given in standard form and ask you to write it in full term. So there are so there will be two situation. First, if the power of 10 is positive, we move the decimal point to right. But if the power of 10 is negative, we move the decimal to left. Okay, so that is the first part of our book, I mean this section, and here is the second part of the explanation of this section, which is full term of a number that it is written in standard form. So I want you to have a view of this in your minds, and if you can rewrite it in your paper or in your notebook, it's going to be perfect. So you can just stop the video for a moment and write it down, this explanation. All right, great. So now, based on this explanation, let's just go through this question and solve as much as possible. Like for example, in exercise 1, it's written write this number in standard form, as you can see. So the first one, if there is no, okay, let me add this point as well. If there is no decimal point, it is in front of the number. But since it doesn't make any change, the authors and the scientists, the mathematician, they don't write it down. For example, here there is no decimal point, so the decimal point is exactly here in the very right of the number. So as you can see, this number is 300,000 and it is a number bigger than 10. So we have to move the decimal point to a place that it makes a number between 1 and 10. So if you move it 1, 2, 3, 4, 5, so it's gonna become 3 times 10 to the power of 5. All right, and look at this one. Okay, I will leave B and C for you, then I will solve D. Okay, if we move, the decimal point is here since there is no decimal point, so if we the number is 328,710, which is a number definitely greater than 10. So we have to move the decimal point to a place that it makes a number between 1 and 10. 1, 2, 3, 4, 5. So it's gonna make 3.2871. It depends on you if you rewrite 0 or not, because there is no other digit after that. So I would love to write it down again. Multiply by 10 to the power of, how many places did I move back? So 1, 2, 3, 4, 5. So here is the standard form of this number. Well, the second question, again, it asks us to write these numbers in standard form. So as you can see here, there is a huge number in part D. There is no decimal point, so the decimal point is here. It must be there. And as you can see, it is 520 billions. And it is a number which is obviously greater than 10. So we have to move the decimal point to a place that it makes a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you just check it, you will see that we need to like move 11 places to the left to make a number between 1 and 10, which is 5.2. 5.2 is a number between 1 and 10. Multiply by 10 to the power of, so 3, 6, 9, 10, 11. So I want you to write this note that whenever we, okay, I will write it here. There are two important notes that you have to note down them. If we have, so star 1, if we have big numbers and want to write it down, write it in standard form, so if we have big numbers and want to write it in standard form, the power of 10 will be definitely positive. As you can see here, all these numbers are like big numbers, let's say bigger than 10. So whenever we turn them to standard form, the power of 10 is positive. All right, but the star 2 said if we have, be careful and pay attention clearly, if we have a number between 0 and 1, 0 and 1, want to write it down, write it in standard form, the power of 10 will be 100% negative. Let me give you two questions here by myself. Let's say if we have 250,000, okay, 250,000. It is a number bigger than 10. So the question is, write it in standard form. So you can see that the decimal point is here. So 1, 2, 3, 4, 5. It's going to become 2.5 multiplied by 10 to the power of, since the number is big, which is bigger than 10. So if you want to write it down in standard form, the power of 10 is going to be definitely positive. But imagine if you have something like this, 0.0000721. So it is a number greater than 0 and less than 1. If you want to write down this number in standard form, we need to move the decimal point to a place that it makes a number between 1 and 10. Alright? So it is between 0 and 1. That's why we need to move this one to right. 1, 2, 3, 4. So it's gonna come here and it will become 7.21, which is a number between 1 and 10. Multiply by 10 to the power of. So we said, according to the start 2 notes, if the number is between 0 and 1, the power of 10 is going to be negative. So 1, 2, 3, 4, negative 4. Add this one to your notebook as well, please, these two notes, because during the examples we need them. Now, here there is a question. It says these numbers are in standard form. Write each number in full. So if you want to write a number in full, if the power of 10 is positive, we move the decimal point to, oh, sorry, right, spelling mistake. My bad. I'm sorry for that. All right, no problem. If the power of 10 is positive, we move the decimal point to right. If the power of 10 is negative, we move the decimal to left. Okay. So here the power of 10 is positive. We need to move this decimal point to right. How many place? It depends on this exponent. So it is 3. So 1 place. And for the other two, we need to add zeros. So it's going to become 5, 4, and 2 zeros. So as you can see, the decimal point from here, 1, 2, 3. So it's going to come here. Depends on you want to write it down or not. Again, the power is positive. So we need to move this decimal point 6 places because the exponent is 6. So 1, 2, and how many zeros do we need to add? 4 zeros to make that 6 places. So 1, 4, 1, 1, 2, 3, 4. Alright, so I'm going to leave C for you and let's just do D 2. So the exponent is 7, positive 7. We need to move to right. How many places? 7 places. 1, 2, 3. And how many zeros do we need to add? 4 zeros. So 8, 7, 2, 5. How many zeros? 4 zeros. 1, 2, 3, 4. Alright, so I will leave C for you guys. Here are the distances of some planets from the Sun. Write each distance in standard form. So as you can see, we are dealing with big numbers. Alright, these are the name of like 3 planets: Mercury, Mars, and Uranus. Okay. So the first one, as you can see, it is 57,900,000. Alright, so the decimal point is here. If you want to like write it in standard form, we need to move this decimal point to a place that it makes a number between 1 and 10. Here clearly the number is bigger than 10, so you must remember that the power of 10 is going to be positive at the end. So 1, 2, 3, 4, 5, 6, 7. So it's gonna make 5.79 times 10 to the power of, okay, how many places did we go back? 1, 2, 3, 4, 5, 6, 7. Positive 7. Alright, so I will do the Uranus and you have to do Mars by yourself. Let's come here. Okay, the number is 2,870,000,000. Alright, so the decimal point is here. We need to move it back in order to make a number between 1 and 10. So how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to make 2.87 times 10 to the power of, how many places did we go back? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the power of positive 9. I will leave this one for you. Alright. Just wait a second. Perfect. I hope that guys up to now you are following the video. Let's make some change in our voice. Perfect. So here are the areas of 4 countries. Which countries has the largest area? The numbers are in standard form. Let's turn them to the full term. The first one, all the numbers, they have like positive power of 10. So the first one, it's gonna become 9, 6. Okay, the exponent is 6. So we have to move the decimal point 6 places to right. Here is 1 place. How many zeros do we need to add? 5 0. So 1, 2, 3, 4, 5. So the number is going to become 9,600,000 kilometers square. The second number is going to become one place here, and we need 5 zeros. So 1 900 and 50. So the number is 1,900,000 kilometers square. What about the Russia's area? So the power of 10 is positive 7. We need to move to right 7 places. Here is 1. So how many zeros do we add? Do we need to add 6 zeros? So 1, 7, 1, 2, 3, 4, 5, 6. So the number is very bigger than the others, which is 17 millions. And the last one, it is 2.7 times 10 to the power of 6, the area of Kazakhstan. So if we move this decimal point to right, because the power is positive, 6 places, here is 1. How many zeros do we need to add? 5 zeros. So 27, 1, 2, 3, 4, 5. So what is going to be the number? 2,700,000 kilometers square. So clearly you can see that which country has the largest area? Of course, Russia. So the largest area I refer to Russia. And which country has the smallest area? Well, we have 2 million here, 17 million here, and 1 million here. So, okay, the Russia was the largest one. Okay, let's skip this one. And we have 9 million here, 1 million here, 2 million here. So which one is the smallest one? Of course, the area of Indonesia. Okay. Indonesia. Copy and complete this sentence with the whole number. Students have problem with this question, but listen to me to make it clear to you guys. The largest country is approximately blah blah times larger than the smallest country. In order to compare the largest one with the smallest one, we have to divide the largest one by the smallest one. So if you go and check it, if you go and check this division, which is 17 million divided by the smallest one, which is 1 million. Oh, sorry, 1 million and where is it? 900. Okay, if you do this division, I'm pretty sure you're gonna reach something like 9, approximately 9, I guess. We can check it later. So this 0 will go with this 0, this one will this one, cancel these two as well. Then 170 divided by 19, I guess, yeah, it's somehow equal to approximately 9. 8 point something, so which is, if we round it, it's gonna become 9. Right, let's just make sure whether it is 9 or not. Okay, let's do this division. 170 divided by 19. So in 117, how many 19 do we have? I said, okay, let's just try 9. 9 times 9, 81. So 1 here, 8 here. 9 times 1, 9 plus 8, 17. So it is bigger than this one. So almost 9. Yes, approximately it is equal to 9. So it means, look, it's better for you to know the meaning. What does it mean, this part? See, so the largest country, the area of the largest country is approximately 9 times larger than the area of the Indonesia. All right. So right now in question 6, we are going to deal with tiny numbers, very, very small numbers. How can we turn them to standard form? Okay. Let's again come back to the notes and check them again. It says, first we need to make a number between 1 and 10 by moving the decimal point. But here we wrote it down that if we have a number between 0 and 1, as you can see, these numbers, all these 4 numbers are between 0 and 1. They are neither 0 nor 1. If you have such a situation and want to write them down in standard form, the power of 10 will be negative. All right, so let's check 2 of them. I will leave the others for you. I would love to do C and D because they seems like harder. Okay, the number is between 0 and 1. So we need to move the decimal point to a place that it makes a number between 1 and 10. If you move it here, 1, 2, 3, 4, 5. So it's going to make 6.691 times 10 to the power of, how many places did we move? So 1, 2, 3, 4, 5. But remember, since the number is between 0 and 1, the power of 10 is negative. How about this one, part D? So again, we are dealing with a number between 0 and 1. So in that case, we need to move the decimal point to find a place that it makes a number between 1 and 10. 1, 2, 3, 4, 5, 6, 7. So it is going to be 2.05 times 10 to the power of, how many places did we move? 1, 2, 3, 4, 5, 6, 7. But negative 7. Alright? So I will leave A and B for you, guys. These numbers are in standard form. Write each number in full. So we are dealing with negative powers of 10. It means the number are going to be small at the end when we turn them to full term. I will do A and D, and I will leave B and C for you guys. So 1.5 times 10 to the power of negative 3. Whenever the power is negative, if the power of 10 is negative, we move the decimal to left. How many places? It depends on the number of the exponent. So here the exponent is negative 3. Alright, so we need to move the decimal point 3 places to left. 1, and we need to add 2 zeros. 1, 2. So 1, 2. So it's going to come here. So the number is going to become 0.0015. From here, it came to here. 1, 2, 3. And let's go to D. So the exponent is 4, negative 4. Since it's negative, we must move to left. Alright? So 1 place here. How many zeros do we need to add? 3 zeros. 1, 2, 3. So it's going to come here. So the number will become 0.123. And the number, you have to rewrite it again. Alright, so originally, here is the number. If you turn it to standard form, we are going to get this one. And vice versa. If we have the standard form and wanted to turn it to this full term, we have to do like this. Alright, so the mass of an electron is this number, 9.11 times 10 to the power of negative 31, which is a very, very small number. This is like this in this form. So in part A, it says how many zeros are there between the decimal point and the 9. So the number is 9.11 times 10 to the power of negative 31. So since it's negative, we need to move to left. How many places? 31 places. So here is 1. How many zeros do we need to make these 31 places? 30 zeros. So that is the answer of the question. It says how many zeros are there between the decimal points. So here it's going to become like 0, 0, 0, 0, and 9, 11. So between the 9 and this decimal point, there will be 30 zeros. Work out the mass of 1 million electrons. Give the answers in kilogram in standard form. Okay, 1 million electron. 1 million is equal to 10 to the power of 6. So 10 to the power of 6. Here is the mass of only 1 electron. What about the mass of 1 million? So we have to multiply this one by 9.11 times 10 to the power of negative 31. So here is a tricky question, honestly. Later on, I guess in the next section, we will study about if we have power term with the same base, if we multiply them, we are going to keep the base and add the exponent. So write this number 9.11 times. Now we have 10 to the power of 6 times 10 to the power of negative 31. So keep the base and add the exponent. So 6 plus negative 31. Here is a question that I want you to think about. 6 plus negative 31. The signs are different. So subtract them. 31 minus 6, 25, and keep the sign of the bigger number, which is negative. So here is the mass of 1 million electrons. Give the answers in kilogram in standard form. So if we give this answer in kilogram, by the way, it's in kilogram, and it is in standard form because the number is, the first part is a number between 1 and 10, which is 9.11 times a power of 10. That is the final answer. So I don't know whether you are with me up to now, up to these seconds of the video or not, but we solved like most of the questions, and I'm pretty sure that I gave you the main idea of this book, which is it consists of two parts. First part, how to write big numbers and very small numbers in standard form, and how do we turn the standard form to full term when we multiply by positive and negative powers of 10. So in order to not make the video like very long, I'm not gonna solve like all the questions here. I will just solve some questions that I believe they are like kind of problem for you, because like listening is very hard. I hope that you guys love the video and get the idea from it. That question is easy. I want you to like find the largest and smallest by turning these numbers into the full term. Explain why this number is not in standard form. Why this number is not in standard form? Because this part is not a number between 1 and 10. It's 65, which is bigger than 10. So you have to do it like this: 6.5 times 10 to the power of, instead of 4, it should be 5. All right, great. Now here, by the way, it is the answer of part B. Write this one in standard form, so I will leave this one for you guys. Just like this one, you can just do it. It will become 4.83 times 10 to the power of 7. I gave you the answer. Write this number in standard form. Okay, write these three numbers in standard form. You may just send it to me in private. I will check it for you. Do this addition. Write the answers in standard form. Okay, I will do like two of them. 12 and 13 are almost the same. So let's just do two of them, then I will leave the rest for you guys. I would love to do this B and this B as well. So I will do the B's. So let's just bring them here. 12 and 13. This B. 12B, 12B. I will solve it here. I hope that you can see it. 12B. So 12B, it says 4.6 multiplied by 10 to the power of 5 plus 1.57 times 10 to the power of 5. Guys, in such a question, you must look for a like term. What is the like term between these two numbers? It's completely clear that it is 10 to the power of 5. So, like, bring it out from each bracket. So if we make 10 to the power of 5 as a common part, if we take it out from here, what will remain? 4.6 plus, if we take out 10 to the power of 5 from here, what will remain? 1.57. Now if we add these two, what we will get? So 4.6, let's say 60, plus 1.57. So if we add them, we are gonna get 0 plus 7, 7, 6 plus 5, 11, 1 here, 1 will go to here, 1 plus 4, 5, 5 plus 1, 6, don't forget the decimal point, times 10 to the power of 5. Here is gonna be the result. So you are going to like separate the common part from each parenthesis. All right, for example, here in 13b, I think you cannot see it, so 13b, let's do it here. 13b, as you can see here, we have 5.12 times 10 to the power of negative 5 plus 5.12 times 10 to the power of negative 5 plus 2.9 times 10 to the power of negative 5. So what is the common part? It's clear, 10 to the power of negative 5. So take it out from each bracket. Let's just take it out. What will remain here? 5.12 plus. What will remain here if you take out 10 to the power of negative 5? 2.9. So 2.9. Alright. So it is equal to 5.12 plus 2.9. So 5.12 plus 2.9. 0 here. Let's line up them. 2 plus 0, 2. 1 plus 9, 10. 0, 1 here. 1 plus 5, 6. 6 plus 2, 8. So 8.02 times 10 to the power of negative 5. That's it. I hope that guys multiply this number. You guys like got benefit from these videos. Question 14. I will leave it for you. Multiply these numbers by 10. Give each answers in standard form. So if you multiply these numbers by 10, what will happen? I gave you a note here. Just go back to this part and listen to it. Whenever we have powers with the same base, keep the base and add the exponent. Inshallah, we are going to discuss about this matter in this section. So I will see you in another video. Take care. Goodbye.